All right, so let's have a look at the first question. Now, they've given you the formula V by T is equals to pi P R S power 4 divided by HCl. And now all you need to do is you need to find the value of C. So let's make C the subject. When you make C the subject, you get pi P R raised to power 4 divided by 8 V by T into L. So let's plug in the values now. C is equals to pi into P. Be careful with P that there is a 10 raised to power 3, so do not forget that. So 2.5 into 10 raised to power 3 into, now R raised to power 4, milli stands for 10 raised to power minus 3, so 0.75 into 10 raised to power minus 3 whole power 4 divided by 8 into V by T, that's 1.2. Do not forget the 10 raised to power minus 6, so 1.2 into 10 raised to power minus 6 into the length 0.250. And therefore, the value of C that you get is 1.035 or 1.04 into 10 raised to power minus 3. All right, so now let's have a look at part B where they say calculate the uncertainty in C. You must remember to calculate the uncertainty in C, you need to find the percentage uncertainty in C first. So percent uncertainty in C is equals to percentage P plus 4 percentage R plus percentage V by T plus percentage L. There's a 4 percentage R because there was R is about 4. Now these are the values that were given already in the table. So let's just plug them in. Percentage C would be equal to 0.05 divided by 2.5 and both multiply by 10 raised to power 3 because it's here. Just want to show you that it'll get cancelled upar or niche, therefore you don't need to write it. Plus 4 percentage R's, that's 0.01 over 0.75 into 100%, plus percentage V by T, that's 0.01 over 1.2 into 100%, plus percentage L, that's 0.001 divided by 0.250 into 100%. And when you solve it, percentage C turns out to be 8.6%. Now to calculate delta C, you need to multiply this percentage error with the value. So 8.6% of 1.04 into 10 raised to power minus 3, and you'll get the uncertainty in C as 0.089 into 10 raised to power minus 3. Now please remember at this point that whenever they ask you to give the uncertainty is always given to one significant figure. 0.089 in 10 to the minus 3 over here is two significant figure. So you will convert this to one significant figure, which is 0.09 into 10 to the minus 3, and then you will write down your final answer. Now finally, to state the value of C and its uncertainty, the uncertainty is 0.09 into 10 to the minus 3 and the value is 1.04. So you write them together, 1.04 plus minus 0.09 into 10 raised to the power minus 3. Now let's have a look at question number 2. You have a ball which is thrown vertically downwards towards the ground with an initial velocity of 4.23 meters per second. And it takes 1.51 seconds before hitting the ground. Air resistance is negligible. So what do we mean when we say that the air resistance is negligible? That means that the acceleration due to gravity is 9.81 meters per second squared. And that is the only acceleration. Remember this. Now show that the downward velocity of the ball when it hits the ground is 19 meters per second. So use the equation V equals U plus AT, where your initial speed is 4.23. Your acceleration is 9.81 and the time is 1.51 seconds. You multiply and you end up getting 19.0 meters per second. Now here I'd like to add that please remember that your gravity is pointing downwards, right? So that is 9.81 meters per second squared, और आपकी जो velocity है उसका भी downward direction है. That is why I've taken both of them to be positive and positive. Now if in any other question, let's say the velocity was not downward, it was upward. So let's say 4.23 नीचे ना होता, ऊपर की तरफ होता, or 9.81 नीचे की तरफ होता, then one of them would have been positive and one of them would have been negative. Remember, when you're dealing with vectors, you must assume one direction to be positive. In this case, because both the vector quantities are pointing in the downward direction, therefore I took both of them to be positive, and therefore you did not have any option. But that's a point worth noting. Now in the next part, they say calculate 3SF, the distance the ball falls to the ground. So use 2S is equals to V square minus U square, 2 times 9.81 times H, which is equals to, now your final speed was 19.0, your initial speed was 4.23, and you get the height H, and H turns out to be 17.5 meters. Now this is an interesting question because they say that the ball hits the ground for a time of 12.5 meters per second. Let's assume the downward direction to be positive. So this is plus 19, and you rebound with a velocity of minus 18.6. You're dealing with vectors, so direction is very important. If you've taken the downward direction to be positive, then the upward direction has to be negative. Now let's find out what is the average force. So force equals change in momentum over time, which is mv minus mu over t. Now the mass is 46.5 grams. So you write it as 46.5 into 10 raised to power minus 3. And within brackets, your final velocity, which is minus 18.6. And then the negative sign of the formula comes as it is. And then the initial velocity is plus 19, so you write 19.0, bracket shut, divide by the time, which is 12.5 milli, so you write 10 is to power minus 3. And when you solve and get the answer, your answer turns out to be 140 newtons. And then they ask you for the direction of force on the ball. It is very important for you to understand that the direction of the force will be upwards. Why? Because when this ball goes and hits the ground, it exerts a downward force on the ground. So the ball exerts a downward force on the ground. So the ground exerts an equal and opposite force on the ball. So the force on the ball should be upwards. Now in this part, they're asking you to calculate the maximum height the ball reaches after it hits the ground. So you know that at that height, the final speed is going to be 0. So we'll use the equation 2s is equals to v square minus u square, where acceleration is going to be 9.81 and the height is h and the final speed is 0 and the initial speed is 18.6 squared. And from here you get your height as 17.6 meters. Now, for the record, let me just state that the acceleration due to gravity is pointing downwards, right? So I should have written this as minus 9.81. So I would have gotten minus on both sides of the equation, like you see on this side and on that side. So minus and minus will get cancelled. That is why my answer turns out to be positive. And why should I take this as minus 9.81? Because it's pointing in the downward direction. This is pointing in the upward direction. I've written this as straight 18.6, which means I have taken this to be positive. Then how can gravity be positive? Gravity must be taken as negative. Just saying. Even if you don't do this, you'll get minus 17.6. You just ignore the negative sign. You'll say the height is 17.6. But actually, you should put a negative sign here because you've written 18.6 over here. This negative sign is from the formula, has nothing to do with this value. But this value is positive, so I wrote 18.6 whole squared. And let's have a look at the last part now. Explain whether the collision is elastic or not. It's inelastic because the ball loses kinetic energy upon impact. You saw earlier that the speed with which the ball hits the ground was 19 meters per second. And then when it rebounded with the speed of 18.6 meters per second. That means that it lost kinetic energy. So it loses kinetic energy upon impact, which means that the collision is inelastic. So pressure is defined as force per unit area. You can just leave it like that. Whenever they ask you to define something, just write down the formula of it and explain the symbol. So for example, if you write P is equals to F over A, just say that F stands for force and A stands for area and you'll get the full score. No need to write it in full words. Now in part B, they're asking you to explain in terms of air molecules why the pressure at the top of a mountain is less than at a sea level. So just imagine that this is a mountain and this is the sea level. So they're asking that if you have an object over here, why does it experience less pressure as compared to the object over here, same object, which experiences more pressure? That is the question. And the answer to that is, when air molecules collide, there is a change in momentum. You must not forget to mention that the collision is with the object. So when air molecules collide with the object. So coming back, when air molecules collide with the object, there is a change in momentum which exerts a force. At the top of the mountain, there are fewer air molecules per unit volume. The temperature is also less. Hence, the speed is less. Therefore, less force and less pressure. Now in this part, they're asking you to calculate the weight of this liquid column, and let's start. So you understand that weight is equals to mg. You know mass is density into volume into gravity. Now you know that volume is base area into height, isn't it? Into gravity. Now you're given the density as 13,600, you're given the base area as 0.45, you're given the height of the liquid column as 0.25, and the value of gravity is 9.81. And when you do the math, you get the answer, which is 15,009. You could round it off to 15,000 newtons. Next, they're asking you to calculate the pressure on the base of the container caused by the weight of the liquid. So let's do this. You know that pressure is force over area, so I can write pressure is equals to weight over the area. You know that the weight is 15,000. Divide that by 0.45, and the answer that you get is 3.3 into 10 to the power 4 pascals. The next part says explain why the pressure exerted on the base of the container is different from the value calculated in 2. Well, the reason is that you have simply calculated the pressure due to this water acting at this base. But you've completely ignored the fact that there will be some atmospheric pressure which is acting from the top, and that is the answer. Which is that atmospheric pressure will also add to the pressure acting at the base of the container. Now in this question, they're asking you to explain how stationary waves are set up inside this tube. So you should understand the fact that you have an incident wave coming from the loudspeaker. The incident wave will travel along the tube and will be reflected by the tube. And when these two waves will overlap, a stationary wave will be produced. And that's the answer. So waves from the loudspeaker travel along the tube and are reflected at the end of the tube. The incident wave and the reflected wave travel in opposite directions and overlap, which causes a stationary wave to be produced. Now in the next part, they say one of the stationary waves that may be formed in the tube is represented by this figure 4.2. Describe the motion of the air particles in the tube at point P and at point S. So you should know that point P represents a node and point S represents an antinode. When you say a node basically means that there is no movement at all. The particle is stationary over here. And when you say an antinode, then there is maximum movement along the tube, maximum displacement along the tube in the direction, because you're talking of longitudinal waves, right? So you should know that because you had placed a loudspeaker over here, and loudspeaker is representing longitudinal waves and not transverse. So if this is the direction of the wave motion, the particles must oscillate parallel to the direction of motions. That is why we're saying that the particles will move a maximum distance along the tube and not perpendicular. Remember, you're talking of a loudspeaker. Loudspeaker produces transverse waves. In this part, they're asking you to find out what is the length of the tube. But they've given you the speed of the sound in the tube as 330 because it's sound, and the frequency is 880 hertz, which is coming from the speaker. So let's solve this. The first thing you do is use the equation V is equals to F lambda. You have the speed, which is 330. You have the frequency, which is 880. Find out what is the wavelength. The wavelength turns out to be 0.375 meters. Now, when you look at the diagram on the left, you will notice that this is antinode, this is node. So this distance over here is lambda by 4. And this is a node, this is a node. So the distance is lambda by 2. So the total length of this tube is lambda by 4 plus lambda by 2. This is the whole length, the entire length, which will be equal to 3 lambda by 4. Now we already have the wavelength as 0.375. So let's just plug that in, divide by 4. And the length that we end up getting is 0.28 meters. State one property of electromagnetic waves that is not common to other transverse waves. Well, they just have one property, and that is electromagnetic waves can actually travel through vacuum or space, which other transverse waves cannot. Now this part over here tells us about the electromagnetic spectrum. One thing I'd like to mention is that you can see the wavelength is decreasing towards this side. So that means that this end has a very high frequency. So this is going to be gamma ray, and this is going to be radio waves. And this is the visible region in the middle. So they're asking you to name the principal radiations and give a typical wavelength. Let's do that. First of all, B, which is this part, that's microwaves. And E is ultraviolet, whereas F is going to be X-rays. Now this is an interesting part where they've asked you to give a typical wavelength for each. So what I'll do is I'll tell you of the entire spectrum, ye aapne yaad karna hai, and then we'll also discuss how do we find out the wavelengths. It's going to be good revision before the exam. So G is gamma rays, this is X-rays, this is ultraviolet UV, visible, infrared, microwaves, and radio waves. Now you must memorize the frequencies at the boundary. So 10 raised to the power 19 is frequency in hertz at this boundary. Remember this. This is going to be 10 raised to the power 16, 10 raised to the power 15, 10 raised to the power 14. That is your visible region. Then you have 10 raised to the power 12. Then you have 10 raised to the power 9. And then you have 10 raised to the power 3. Right? Now, you all understand that C is equals to F lambda, right? Now C, which is speed of light, that is actually 3 into 10 raised to the power 8 meters per second. But please remember that over here, when they're asking you for the wavelengths, they are not at all referring to this number. They're only referring to the power of 10. Power of 10 ठीक हो, तो ये answer खुद ही ठीक हो जाएगा. Remember that this number doesn't matter. The power of 10 matters. So therefore, if you want to find out what the wavelength is, firstly, make wavelength the subject. So you'll write C over F. And the value of C is 10 raised to the power 8 divided by the frequency. Now, which part do you want the wavelength for? You want the wavelength for microwaves. So microwaves are in the region 10 raised to the power 12 and 10 raised to the power 9. You could pick up any frequency in this region. For example, let's pick up 10 raised to the power 10. So if I pick up 10 raised to the power 10, which is somewhere here, so the wavelength of microwaves would be 10 raised to the power 8, which is the speed of light, divided by the frequency, which is 10 raised to the power 10. So when you do that, you will end up getting 10 raised to the power minus 2. So you get 10 raised to the power minus 2. Obviously, there will be a range because microwaves are in this range. Do you understand? So आप 10 raised to the power 12 भी डाल सकते हो यहाँ पे, आप 10 raised to the power 9 भी डाल सकते हो यहाँ पे. You'll be in the range. Next, they're asking you for ultraviolet. Ultraviolet is between 10 raised to the power 16 and 10 raised to the power 15. You could put either of the two numbers. So let's say, for example, for ultraviolet, I put 10 raised to the power 16. So I get 10 raised to the power 8 divided by 10 raised to the power 16. That's like 10 raised to the power minus 8. So I'll put 10 raised to the power minus 8. And then they're asking you for x-rays. Now, x-rays are between 10 raised to the power 16 and 10 raised to the power 19. Pick up any number. Let's say 10 raised to the power 18 utha lete hain. So lambda x-ray would be equal to 10 raised to the power 8 divided by 10 raised to the power 18, which will be 10 raised to the power minus 10. So the key that I'm trying to tell you over here is please do not memorize the wavelengths. Memorize the frequencies. These boundaries are very easy to memorize, and then you can easily convert them into wavelengths. Now here in the next part, they're asking you to calculate the frequency corresponding to a wavelength of 500 nanometers. So you know we'll use the equation V is equals to F lambda. So as you know, the speed is 3 into 10 raised to the power 8 is equals to the frequency times the wavelength, which is 500 nanometers. That's 10 raised to the power minus 9. And when you divide, the frequency that you end up getting is 6.0 into 10 raised to the power 14 hertz. Now in the next part, this part C is actually polarization. Polarization is for May, June 22. So the guys or girls who are giving it tomorrow, you guys are not May, June 22, so you can skip this part. But if you are May, June 22 and you're listening to me, I'm recording this on 19th of October 2021, which means we're looking into the future right now. Remember, ये question ज़रूर आएगा polarization का, because this is a new addition to the syllabus, so they'll definitely check this. Now, what is polarization? Polarization is a phenomenon in which you restrict the wave to pass in one direction only. So let me explain this. So basically, if you have a source, right, the waves are going in this direction, which is, let's say, the x direction. They're also going in the y direction, and they're also going in the z direction. If you want to restrict the waves, let's say this was a light source, if you want to restrict them to pass only in one direction, let's say the x direction or the y direction, that process is called polarization. And let's look at the answer now. So polarization is a phenomenon in which the vibrations are in one direction only. They are perpendicular to the direction of energy transfer. And now let me explain with the help of a diagram. So let's say this is your source and the particles are oscillating in two directions. One is this direction and the second direction is this one. Let's call this as the y direction. Let's call this as the x direction. And this is the direction of energy transfer. And by all angles, it is perpendicular to. So आपने इस तरह imagine करें that this energy transfer direction is perpendicular to this and this as well. So this is 90 and this angle here should also be 90. Right? Now, what you do is you put a polarizer in front. It's like a narrow slit. Now, when you put this polarizer in front, the wave is going to pass through it like this, but it's only going to allow, this polarizer will only allow the particles which are oscillating perpendicularly to pass. ये horizontal को रोक देगा. और अगर आप इस polarizer को यूं रख दोगे horizontally, तो ये सिर्फ x को allow करेगा, y को रोक देगा. So it restricts basically the particles to vibrate in one direction only. That's polarization. Now, this is a question on radioactivity. You've got beta radiation. They're asking for the nature, the properties, what is meant by spontaneous decay. And then we look at the next part. So let's begin. The nature of a beta particle is that it is basically an electron. State two properties of beta radiation. One, it's absorbed by aluminum, by a few meters of aluminum. And the second property is that it can be deflected by electric and magnetic fields. Now, spontaneous means that the decay is not affected by any external conditions such as temperature and pressure. Now you know that beta is 0 minus 1. So this number should be 3 and this should be 2 because 2 minus 1 gives you 1. Part C. Now, you're given the energy in electron volts. So first we need to convert it to joules. Remember the conversion. 5.7 in 10 to the power 3 into 1.6 into 10 raised to the power negative 19, which equals 9.12 into 10 raised to the power minus 16 joules. Now you must remember this conversion, that is 1 electron volt is 1.6 into 10 raised to the power negative 19 joules. This will not be given to you in the data booklet, so memorize this. Now the formula for kinetic energy is half mv squared. We have the energy, which is 9.12 into 10 raised to the power minus 16 should be equal to 1/2 of mass of electron, 9.11 10 raised to the power minus 31, given in the data booklet, into v square. And from here, you will calculate your speed, which turns out to be 4.5 into 10 raised to the power 7 meters per second. In this part, they're basically asking for the difference between hydrogen 2 and hydrogen 3. You must understand that both have the same number of protons or electrons. They're isotopes, which is 1. Because you see, the way to write this is H21 and H31. They're isotopes, so they have the same number of protons or electrons. And to find out the number of neutrons, you will simply subtract the mass number, which is 2, minus the proton number, which is 1, and get the number of neutrons in H2. And similarly, if you do 3 minus 1, you will get the number of neutrons in H3. So they both have different number of neutrons, which you can calculate. So H2 has 1 neutron, like I showed you over here. And H3, helium-3, has 2 neutrons because you'll do 3 minus 1.